got to tell me the speed of the big circle, not just the little circle.
So now, are you aware that Michelson-Morley and the Michelson-Gale, which is the foundation of these gyroscopes, they have a different geometry to the test? Do you know that?
Fair enough, man. Fair enough.
Okay.
But there still has to be a reference frame, man.
Well, no.
What do you mean, well, no? So what is telling me
rotation is
turning?
The Michelson Gale, the rotation is absolute, right? Velocity is not, but rotation is absolute. So I'll show you here.
I understand. That's fair. That's fun to say. But so you're going to tell me that you can detect a small circle, but not a big one. That's what you're basically saying.
Brian, do you know how a gyroscope works?
I understand this, and according to relativity, there has to be a reference frame, period. You can't just say that, hey, I'm turning, because if the light is also turning, hold on, if the light is also turning, you would not know you were turning, okay? So there has to be a still reference frame or a medium, okay? If there's no medium, then there's no turning, okay? So if you claim that Bob proved 15 degrees, you're basically debunking the results of the Michelson-Morley was, hey, since we know we're moving 30 miles a second around the sun, then there must not be an ether. And that was the actual results written in the paper.
Oh,
all right, let me show you this. The top one here is Michelson-Morley. Okay, they had the beam split down here. It went both directions, and I didn't draw them the same length. They're the same length. And then they came back and they measured. They're very simplified. And then Michelson-Gale, they had it, and they sent it around both directions at the same time. So two different beams went one clockwise,
one split at the same time.
Yep. And so when this one rotates, it makes, because the speed of light is constant, it makes the path longer for one of them and shorter for the other one, because it rotates while the light is going through it.
So you're saying we can measure a small circle, but not a big one.
No,
that's what you're saying.
No, this is a Michelson-Gale was actually a gigantic circle. Michelson-Morley isn't a circle; it's an L.
No, my point is if you're going to give us if you're going to try and take away the medium, then we should be able to measure the circle we do around the sun.
We do.
Just like we can measure the small circle.
Oh, yeah.
You should detect the speed, okay?
Sure.
Apparently there's no detection, there's no ether, there's no medium to detect the speed around the sun.
Brian, it doesn't measure speed. It measures angular velocity. Okay, so
and now pull up the Sagnac. Pull up the Sagnac experiment.
Yeah, that's Michelson-Gale. You didn't realize that? Michelson-Gale uses the Sagnac.
Not.
Yes,
it's not, but
I've read
that came afterwards. I understand your explanation for that.
Okay.
But I'll pull up the original.
So I've read it, and the Michelson-Gale measured rotation, of course. But you can measure the rotation around the sun as well. But here's what I think you're missing is you're confusing speed, like linear velocity, with angular velocity. So on the Michelson-Gale experiment and a ring laser gyroscope with three separate
Allow me to explain why I'm not, okay?
Oh, I'm not done yet, though. Brian, I wasn't done with my explanation. It measures one rotation a day of the Earth rotating, and it measures 1/365th of the rotation around the sun. It's significantly smaller, but it can measure that. Right, go ahead.
That's a hell of a claim, but I'm good with that. Okay, but listen. Okay, so the reason, my rebuttal to that is they claim that. Okay, so what they did, okay, is George Aries went to set out to show that it was that us moving and not the stars. Okay, and what he did is he put water in his telescope. Okay, so now stop and think about this. Okay, if water slows down the light, okay, let's just not listen to explanation. Let's think about this. Okay, if water slows down the light, okay, and I'm the one moving, okay, if I'm the one moving, then it shouldn't matter, okay? I mean, it should matter. If it's the light moving, it shouldn't matter. The light's already left the star, okay? And that means however many light years away, the light has already left the star, okay? And it wouldn't matter. But if I'm the one moving, I should have to adjust my telescope, okay? Because I'm the one moving. In other words, the light's coming from plenty different other places. So if the light is moving, then you would not have to adjust anything because the light's already left the star. It's already coming in at a certain speed. Okay, so if we slow the light down, it ain't gonna matter. Okay, if it's the light moving, because the light's gonna take however many years to get here anyway, right? So now, what he found was that he did not have to tilt the telescope anymore at all, proving that it is the stars moving and not us, because light would have come in funky. You would have not got the same light coming in at the same angles. Every star you'd have to adjust different for. It's common sense, bro. People don't understand it. He debunked, and that's why they called it a failure. He failed to prove, and they tried to rename it saying he failed to prove it. Bullshit. Look, he failed to prove that the light is that we're spinning and the light's not.
Well, Aries and Michelson-Morley both had basically the same conclusion. Ether is not, does not exist. That's what.
Well, when I went to Caltech, it said that the results were that that Michelson did never accept the results of that experiment. The results were that there's no ether. He went to his deathbed. He got a Nobel, so he shut up. But
doesn't change just because he disagreed with it. Doesn't mean that everybody else doesn't understand it. Now, Aries, I love the final conclusion from Aries. Says, I think myself justified in concluding that the hypothesis of Professor Klinkerfues is untenable. Professor Klinkerfues is untenable. So it was a falsified hypothesis by Professor Klinkerfues. So both of those were about testing whether or not ether was existed, and both of those had the same result through different testing methods. Ether doesn't exist. That's
funny.
That's what they both. It's not funny. That's what both of them
funny. Well, because
concluded.
Michelson said he set out to prove Earth's absolute motion through the solar system. That's what he set out to prove when he first started. He was the first one to make the interferometer back in Germany. Okay, like 8 years before the Michelson-Morley. Okay, and he set out to prove in his paper. He set out to prove there's absolute motion in space. That was his life projection.
But his intentions. His intentions.
Okay, if you don't have to tip the microscope. Okay, one thing. If you don't have to tip the telescope, then light should come in at every different angle. I mean, if light is different distances away,
then it's not using a medium. That's the conclusion. That it's not using a medium. That's what the conclusion was. But now here's the cool thing. I'm sharing right now on my website mctoon.net/spin measurements of the rotation of the Earth using optical gyroscopes similar to Bob Nodell, much more detailed. In fact, some of these, they're able to actually measure the annual wobble of the Earth, which is just a few meters, about 8 meters at the poles is the wobble of the Earth. Now, optical gyroscopes are great. They're super precise, but they're not the only way to do it. I have some other ones here. Here's one where they used a diamagnetically levitating gyroscope. It was actually a plastic sphere. They used a 15 Tesla magnetic field, and they suspended this plastic sphere. Now, plastic is diamagnetic, so a very strong magnetic field can cause it to repel it enough to hold it in suspension. Then they spun it up. They used they got it spinning, and then they measured the change in rotation of this sphere. Now, because it was hovering and not touching anything, it wasn't affected by other things. So by friction, they were actually able to measure the rotation of the Earth in the right plane using that. They did a similar thing using this one, detection of Earth's rotation using superfluid phase coherence. This is about liquid hydrogen or liquid helium-3.
I would say that, using liquid helium-3, Flat Earth predicts that. That's what we think is up there. That's what we say is up there.
No.
Helium-3 has got zero viscosity.
It was in a lab.
Hold on. This exactly. But helium-3 is what goes up there between hydrogen, helium. Okay, helium has zero viscosity. Okay, so
this is
whatever rockets are up there. Well, if you don't want to hear what I have to say, that's fine.
Oh, go ahead. The craziness abounds. Let's hear it.
That's what we say is like basically the ether. It's like fucking helium-3 and other isotopes that are barely detectable. Okay, and that we're just now being able to detect. But helium-3 hits like right before absolute zero, which the Soundly rocket, the Google, the Go Fast rocket hit like recorded right there at like I think negative 272 degrees. Right when helium-3 turns into helium-3, and the characteristics of helium-3 is got zero viscosity, okay, no refraction, okay, and so in other words, you could fly a rocket through it with zero friction whatsoever, okay. They made a little fountain.
It still has density.
Yes, and so there's a fountain they made with it that's ever-flowing mountain. As long as they maintain that temperature, it'll continue on forever. It's there's no way to contain it. Hold on, there's no way to contain it. And as soon as it loses that temperature, it's gonna go out of phase. Okay, so that would make a layer. Hold on, I'm almost done. It's gonna lose phase. It's gonna drop out of helium-3. Okay, it's gonna once you heat it up. Okay, it's gonna drop into helium. And
it's actually
still a boundary.
Still helium-3.
You have a boundary like a Kármán line.
It's still helium-3. It's just
we call it helium-3.
When it goes from liquid to gas, there's a name for that. We call it evaporation.
Yes, exactly. But that is a whole nother state of matter, dude. You're going to say that the helium-3 superfluid is what matter? So a normal state of matter is superfluid now, Michael? It's called superfluid. Okay.
It's just the properties of liquid helium. That's it. It's just the properties of liquid helium.
Then you got some research to do. Okay. Can I pull something up?
Give me some of that superfluid.
Do you mind if I pull up a video real quick?
Something like that.
Oh yeah, go ahead. All right. Oh, I'm sharing. Hold on. I'll stop. Oh, darn it.
So can you get superfluid by the gallon or no?
It's incredibly expensive and very difficult to maintain. So it doesn't just happen.
I know it doesn't just happen, but if you reach a height where the temperature is negative 272, like the Go Fast rocket showed, then it would naturally happen. That's my whole point.
There was a thermometer on there? I've never seen a thermometer on the rocket.
You can call it a thermometer or call it whatever you want. It said negative 272, bouncing between 71, 72. So call it whatever you want.
There's another thing that you need in order for helium to be liquid.
Yeah, no pressure.
No, high pressure. High pressure.
Bullshit. No, you're wrong. Okay, MC. You say you need high pressure? Is that what you're saying we need?
You need pressure to maintain.
Yeah, we need pressure, right? So everything happens quicker with higher pressure. Is that what you're telling me?
I'm saying that there are, in order to maintain a liquid state, you need multiple things. You need pressure and temperature.
And able to even reach that temperature, you need almost zero pressure, period. As close as you can get to a vacuum to even reach that pressure. That's the leaching process they're speaking of. That's the leaching process they're speaking of, is getting rid of the pressure to even achieve that low of a temperature. Okay? What are you talking about?
Brilliant.
You laugh all you want, dude. You're making a fool of yourself, bro. What do you think we do? What do you think we do in refrigeration? We take away, we put up the pressure, and then we expand it. Okay, so it's the expanded pressure.
When you expand it, what does it do? It changes when you decrease the pressure. It changes from liquid to gas.
it gets colder, right? What's it do? It gets colder. So all the pressure is coming from the ground.
It changes phase from liquid to gas when you reduce the pressure.
Okay, so don't we have pressure up there at the top of Mount Everest? Don't we?
Have less. Michael? We have less pressure.
Yeah, right. We do have pressure up there, right? Where did it come from? Is it created up there? No, the peak of Mount Everest. Where do you think it came from, bud?
Gravity pulls down. And
no. Where did it come from?
Where did what come from?
Where did the gas come from?
From the Earth.
It come from the ground. And it made it up there 6 miles, right? And it also made it up there 20 miles. So it's doing what? It's expanding, is it not?
Yeah, less pressure, so less likely to be...
So the gas is expanding.
Less likely to be
colder.
liquid. Less likely to be liquid.
Right. And it's going to hit a certain temperature. And according to the Go Fast rocket, when it hit damn near absolute zero, it did the same thing that we show in our labs today. It's called helium-3 superfluid, okay? And it takes absolute low pressure, not high pressure, dude. It takes a damn near negative pressure. I mean, it takes one of the best vacuums we can achieve, dude. Are you kidding me?
No.
Wow.
Wow.
That was awesome.
That's awesome.
Wait a minute. Wait. According to Michael, we need to pressurize something to cool it down now.
No, we need to pressurize something to keep it in liquid state.
No, it's not liquid. It's a superfluid. It takes almost damn near perfect vacuum and a perfect zero temperature. What do you think they do to reach these damn near zero temperatures, Toon? What do you think they do? Do you think they add pressure?
They go to Hogwarts.
You got no common sense sometimes, brother.
Yes.
I still love you, though, man.
They're like, Adabra-cadabra.
Yes.
Something like that. My goodness, that was a load of crazy. But here's the deal, people. Just so you know, do study ideal gas law and the associated other laws. Lower pressure means things go from liquid to gas easier. All right, I got a couple things I got to read. I have another person coming in 15 minutes, Brian. It's going to be a second stream. This is going to be Curtis Chris. So if I could read a couple things here, I think we have some things going back to reflections and rainbows. From Kiros says, so if there were multiple reflective surfaces, would you see more rainbows and in multiple orientations? That's a good question.
I'd say yeah, probably.
Yeah, so there you go. So you could get in your tent there, you could get like 3 different mirrors and then have different rainbows maybe. Delcos,
I've only did one, but I'm not sure. I've done one.
All right. Delcos Man says this show has gone from Battle of the Egyptians gods to Larry the Cable Guy, another amazing Toon experience. Brian, are you Larry the Cable Guy, or are you you do something else, don't you?
Yeah, man, I do. I own a concrete business.
There you go. I'm building a deck. I might need some concrete. I'll give you a call.
Yeah, you get me there. I'll hook you up.
I'm in Minnesota. I don't know where are you?
Well, if it's on the way to George's, man, you just got to catch me right when the lake is frozen. But when it's starting to thaw, but it's not quite unthawed. So I want to go up there and do an experiment.
You going to George's? Oh, well, definitely we should.
Yeah, but I got to catch it before the lake is thawed. But when it's not too cold to do your concrete, man, that'll give me an extra reason to come up there.
All right. No, I'm kidding. I'm going to do it myself. I actually have a little 1-bag concrete mixer I'll use. So, all right. Connell Silverfur says, I'll summarize Globebusters with 6 words. A 15 degree per hour drift. Thanks, Bob.
Cheers, Bob.
Truth Nerds says, if Earth has a cheese dome, why are there flies? A cheese dome. The dome is made of cheese. I thought just the moon was made of cheese. King Crew, can you confirm moon made of cheese, and what kind of cheese is it?
I can confirm the moon is made of cheese.
And
absolutely.
What kind of cheese?
Mozzarella.
Mozzarella. That's a good cheese. Brian, if the moon
is definitely mozzarella, man. Definitely mozzarella.
Oh, we got 2 mozzarellas in the chat. What kind of cheese would you want the moon to be made of? I'll go provolone. It's
mozzarella's more reflective.
Oh yeah, okay.
Yeah.
the reflective properties you need to take into account.
Yes.
All right. Very good question, truth nerds. Alyssa says, why is all navigation based on a globe? I think that's for you, Brian.
Man, if you're gonna, sorry about that. Can you hear me?
Yeah. Did you get electrocuted?
Yeah, sorry about that. I got bombed in on. But man, I'd say yeah, if you map everything out, longitude, latitude, then you're gonna match globe coordinates.
Yep. We got it. Okay. Stringer News 1 says, oh my goodness, is this? They must have been talking about a cheese dome. He says, if Earth has a cheese dome, why aren't the flies outside? Oh. I must have missed a cheese dome thing in the chat or something. That's amazing. So, good question. Why aren't the flies outside? Mr. Tube, first name Fa, says, tell the Flurf that his audio is jacked up and to fix it, please. So, Brian, your audio is jacked up.
Yeah, well, we're about done anyway, right? We're about done anyway. But
yes.
Yeah, I get that a lot.
Magellan for 5 Sega Genesis dollars or Singaporean dollars says, hello, MC Toon from Singapore. Another rough day of dealing with the wind passing by at Mach 1.3. Singapore's on the equator.
That must be to you, right?
No, yeah, it's tongue in cheek there. He's on the equator, so he's rotating at 1,000 miles an hour, which is about Mach 1.3. There it is. Humphrey Pushcart for $6.66. Hail Santa says this exceeds Wolfgang Pauli not even wrong level dumb. Bet you this fellow does not understand the quote. Are you familiar?
Man, I didn't even hear the quote, much less understand it.
From Wolfgang Pauli's
Brilliant.
Not Even Wrong. Truth Nerd says a cheese dome is made of glass. It's for covering cheese. Everything makes sense now.
Indeed.
There we go. Magellan. Let's see. It says Captain Moron, Carmen Line is not a boundary layer. It's an arbitrary location defining the start of space. Did you know that, Brian?
Did we lose Brian?
No, he's still. Well, it looks like he's still here.
Oh.
He has had. I think he's on his phone in his garage, so he might have been dropping. Let's get a little bitter. The Sun Express.
Special ed stuff right there.
And keep the helium from helium-3 to something else when it stops being a super. What do you think the liquid in a propane tank is? This is the most basic stuff around. Come on. Yes. Oh, Brian's coming back.
Like I said at the beginning, it's hard to fathom. You got to explain the rainbow to a grown up.
Boy, they think you dropped. They quick to talk shit about you, ain't they? No, we're debating, and I don't even know what is in a propane tank, you know. And I don't know what air is. I mean, really, man. I have to extend the courtesy of all the sarcasm, at least straight to my face.
Yes, man. It baffles the mind.
All right, I'm gonna send. Let's see.
Have you figured out how rainbows work yet?
Don't get off track.
Yeah, man. Yeah. Hey, I'm sorry for calling you a lying sack of shit earlier, man.
It's all good. It's all good.
I think what he meant is he's sorry that you are one. I think definitely that's what he's saying.
No, I meant that I don't believe you unless you show me, but I still love you. That's what I meant.
All right. Delcos is wondering, asking Brian, what is the liquid in a propane tank?
Just dismantle the propane tank, and you could try and call that liquid, but it'd be kind of like a thick air, I guess. But if anybody wants to hear a cheap way of storing
I meant to say a thick gas. Boy, be careful, boy. They'll jump on anything. They want to call the propane a liquid, you know, and I was saying it's more like a thicker gas. But careful what you say. They'll get you for every little misspeak when they don't have anything legit. And tonight don't look like he had nothing legit.
I've got a good little method.
okay, how do you store hydrogen?
Okay. Well, we use like muriatic acid in the concrete industry to clean concrete.
It's just
And it's
hydrochloric acid. Yep.
Yeah, it's hydrochloric. I mean, you can purify it, but you don't even need to. But just take scrap aluminum and take a propane tank off. It's probably better that you use a portable air tank. The valves come off pretty easily, and plus they're made for pressure. Excuse me again. I would say that the propane tank, I would about 150 pounds, but them air tanks, man, they're not even in the red at 200 pounds of 200 psi pressure. But you take the valve off, you drop in the scrap aluminum cans, foil, whatever, and then lean it all to one side, and then gently tilt the tank, and then put in the hydrochloric acid and put the valve back on, and that makes the hydrogen. You can fill it for balloons or whatever, torch, whatever.
Okay.
Why is it when I hear you talk, I always think of a redneck trying to explain how NASCAR works? It's like a lot of words, none of it makes sense.
I don't know, maybe you're back.
Oh, okay, all right.
I'm playing with you, bro. I love it.
I think that guy's got it out for me a little bit for calling him a lying sack of shit. But let's be honest, though. That's cool. He said, I love you, extended the courtesy. But let's be honest. I caught him on the spot asking him, has he ever did the indoor rainbow thing? And everybody knows he didn't. He's like, yeah, plenty of times. Yeah, right. My big brother's 60. But still, he got it out for me, man, with that shot. So anything he throws my way, I probably deserve.
All right, Magellan, has the guest heard of the Epstein drive? It's also based on helium-3 superfluid, and it's being used by NASA for faster than light experiments.
Used by, I sit here thinking of NASCAR. Used by NASCAR. But no, man, I was thinking though. Let's just be real for a second, okay? It takes temperatures of damn near absolute zero to get the superfluid, And I'm not talking about a Einstein-Higgs condensate. I'm not talking about like on a molecular level. They have done it in the lab. You can look it up on YouTube or go to my channel, Flat Earth Test, and see. God dang, I'm not sure that that's how they did it.
I'm not
sure that's what's up there, but if it is up there, and you could picture like heat coming, like jumping off of a hot stove. I mean, that would be like how rockets would work. If it's that cold and you apply a little heat, it would jet your ass around. I mean, it's just a thought, man. It's possible, right?
Let's see.
Sure.
All right, so Jayacito says, state you can use higher pressure. All right, here. Let's see. All right, Jayacito. I'm behind a bit, but he's actually correct, Toon. I've worked with superfluid helium-3, and to get it to a superfluid B phase, typically you want low pressure, very low pressure. For its superfluid A state, you can use higher pressure. Superfluids are much different than normal liquid. All right?
So McToon was wrong. Even the almighty McToon is wrong sometimes, people. Nobody's always right. At least he didn't pitch a fit. I mean, like a Rumpus would have or something like that. He just got to update his script a little bit and put in. He's telling me to go learn gas law. You don't even fucking know that low pressure goes with low temperature. I mean, it's just unfucking believable. Most machine head mathematician types, they're not very gifted in the common sense department. So they pay a lot of attention to detail, but outside of what's explained to them, they're clueless. But very good with certain things. Everybody's got their own talents. And thinking outside the box is not one of his, in my opinion. But I had a good time. It wasn't too bad.
There you go.
Okay. That's cool, man. Yeah. I mean, I don't know everything about it. I've never made it, being honest, but I know it's hard to make. But I've seen the people who made it. They seem very smart.
All right. Robert Williams says, what do you call an atom with one proton and two neutrons?
Now, right here, I'm trying to say hydrogen. I'm muted, though. I didn't even realize I'm muted.
What do you think?
Call it a hot day?
Hydrogen?
Is that tritium? I think.
Which is hydrogen, right?
It is an not an asymptote. Oh my gosh! Yes, it is a variation. My goodness, why am I not getting the right word? But yeah, it is essentially hydrogen.
It is hydrogen, McToon.
Because of one proton. And what do you call an atom with 2 protons and 1 neutron?
Anti-hydrogen.
Oof.
No, that would be a helium variant. So,
That was funny. I don't care who you are, man. That was funny.
all right. Batman says, hello, MC Toon. When I Googled electromagnetic wake, I get electromagnetic. What he heard Bob Nodell say. In order for any, and that's hurricane, don't know. How would it not, it wouldn't work because elevation, none of that matters. None of.
I appreciate it.
All right.
What pressure does aluminum stop reacting with hydrochloric acid? Any given pressure, just it doesn't have to be perfect, just an estimate. And also, what pressure does it stop reacting? And also, does it have to have oxygen?
There you go.
Or air.
Well, air is a generic term, but probably you do.
Brian, let me ask you, what do you think air is? Like, what's it made of?
What was that?
What's air made of?
I mean, I know what it's supposedly made out of, like 79% nitrogen, 19% oxygen, 2%, of the other gases. I mean,
Argon, yeah. Okay,
Yeah.
no, let's make sure. Okay.
Okay.
A lot of first think air is just oxygen, so let's making sure.
Yeah. Okay. All right. Quiddy says Mallory debates Punchy and Quiddy's. Does that means Mallory's gonna wake? That is what too soon. Let's see. Charlie says any superfluid naturally in the universe. Yep.
I will say this real quick. That is pretty interesting that one rocket showed the temperature getting down that low instead of climbing up into the thermosphere temperatures they tell us. But was it a mistake or was it error or what?
Heat and temperature are different. Learn about that. So Magellan says, has the guest heard of the simpleton particle? It's composed of 1 Cretan quark and 2 derps. You heard of that?
And a muon.
Yes. All right. And Rocky Bixby for 5 Canadians, his hair is 95% keratin.
Hair.
There you go. Brian, thank you for coming on. This has been enlightening.
Yeah, that was awesome, bro. I really appreciate it. I appreciate it on the spot, man. And like I said, never taking that personal, man. I love y'all, man. Take it easy.
All right. Thanks, Brian. So we've